Okay, let me explain what I'm expecting for this proof. Okay. First of all, this part is already a definition of D, right? So it's kind of reversed, right? So it's better to say let this, right? That's the definition of D. And the meaning of that on R2 is these two elements or the coordinates of that ordered pair should be real numbers, right? So D must be from the Cartesian product of two real number sets to real number, right? Because the result is just real numbers, right? So you should change that setting like that. So it's better like putting this let these over there and with that, right? So that is enough, and not x and x. That is, what is the meaning of x there, right? So then the first one is yes, you did it right. Okay, that's good because by the definition of it, you only have two choices, either 0 or 1, right? So no matter what x, y you choose, that value must be greater than or equal to 0. So the first part is great. Now the second one. Okay, if they are same, then the distance is 0. And you take a kind of reverse of it, and the other one is also 0. But is it the property that we have to satisfy in the definition of metric? That's the question. So please check what the second property in the definition of it, right? This is not right. It's totally just different. Okay. So, for example, let me say in the second property is if the distance is 0, right? Or right, the value is 0, then x must be equal to y. And if x equals y, then the d of xy must be 0. You have to prove that two things, right? So for example, in this portion, okay, is yes, you just to show that direction, right? So you accept the equality between x and y's. Okay, good. Then can you say the d of xy is 0? Yeah, by the definition of the d here, if they are same, then it's 0, right? Okay. And if they are different, then it's 1, right? So that's the one direction, right? But how about the other direction? Like let's say temporarily that is P and that is Q. So we want to prove P implies Q. Then it's a little bit difficult to prove it because we don't have enough kind of information about it. But in logic, P implies Q. It has the same logical value, like not Q implies not P, right? Okay, so that's from logic. So instead of this direct proof, P implies Q, how about starting with this one, right? So for x is not equal to y, then what do you have? If x, y is the same, then the value must be 0. X, the other cases means what? X is not equal to y, and value must be 1, right? So in this case, yeah, it's not 0, right? Okay. Because it should be 1. Then, if you can prove that, right? Not Q implies not P. We just prove it. That means what? You can claim P implies Q, right? So if, therefore, dxy is 0, then x equals y, right? That's the opposite direction of it. Can you follow me? So not this one. The first part is y, but look at what direction of that is, right? From the second properties, right? So please rewrite that one according to that. Now the third one is whether you can kind of change the order of xy or not at this moment, right? So in this case, we don't know whether x is 0 or not, right? X can be any real number, right? Y is also that. The situation is, okay, let's start with that. If dxy is 0, then dyx is also 0. Can you say that? Of course, if that is a given condition, then you can say what? By the definition of the x must be y, right? X equals y. That means what? Y equals x. Then by that order and by the definition of D, you can claim D of y comma x is 0, right? Okay, good. So that's the first case. And that is only for that. So you did it right here. So let's say the other cases. So of course we need this one, but you don't need to mention it. Just say dxy, maybe not 1 or maybe not equal to 0. It's up to you, right? So, but this is enough, okay? And not this one. That's what you want to get, right? So what does that mean? D of xy is 1. Then x is not equal to y, which means y is not equal to x, which means that, right? Same arguments. So altogether, no matter whether the d of xy is 0 or 1, you can always claim that this value is same as that one, right? dxy is equal to dyx. Okay? The most complicated ones, the triangular inequality. So if you want to separate the cases like that, yes, you can do that. But you have to thinking about x, y, and z, right? So sometimes they are same, sometimes they are same, sometimes they are same, and maybe they are different. So it's very, if you're really looking for case by case, then you have to separate into many different cases, right? But I believe there might be a simpler way to do it. Okay? So that's your task. You have to figure out that. But as a general, let me just guide you how you're going to kind of look at this part. Okay? So you're saying if x equals y, then that must be 0. And if you change it, it should be same because by the number 3, right? Property before. So you can accept that. And what this x is, right? No, g must be real number, right? All numbers are real numbers here. And you don't need to restate here again, right? It's always true. This is defined that way, right? You don't need to mention again. So you just pick arbitrary real number z. Okay? And if they are same, then you can claim something. If they are not, then, right? So you're almost there, but it's not really quite true, okay? Like this. You're just showing only few cases, right? But like I mentioned before, if you want to show this way, then you might think like, okay, x, y, z all same. Second case is x, y is the same but not z. Third case is x, z is the same but not y. Okay, then the next case is what? X is not same as y, and that is also not same as z, right? And I believe that covers all different cases. Then try to show that inequality for each of these different cases, right? You're almost there, but you put too many unnecessary informations, and sometimes it makes trouble. And okay, so you don't need to mention those stuffs, right? So in the beginning, you says x equals y. Okay, good. Then how about equals z2, right? Then that is 0. dy is also 0. So sum of that two is 0, which is greater than equal to 0, which is xz, right? And try to prove in that way. Okay, you're almost there. So I think you can do it that way. Okay, hopefully this is helpful.